So in this video I'll show you how to complete inferential statistics when you have one independent variable but more than two conditions. So a within subject design where everybody takes part in all of the experimental conditions and you have more than two of those conditions. So here I have some data in an SPSS spreadsheet. This is from a group of adults who participated in an experiment where on 3 separate nights they had 3 hours sleep, 6 hours sleep or 9 hours sleep. And when they woke up in the morning they were given a general test of memory and orientation. So I have a hypothesis about the fact that when you have less sleep you're going to make more errors on this test. So I've looked at the data and I know that scores on this test are normally distributed, so I can use a one-way repeated measures ANOVA. So one way because it has one independent variable that I'm looking at. So in order to do this analysis I go to Analyze, General Linear Model and Repeated Measures. So here it's asking us for the within subjects factor, so the independent variable that has been manipulated within subjects, and it's hours of sleep, so I'm just going to give it a name that reflects that. And I've got 3 separate conditions. So I've got 3 levels, 3 hours, 6 hours and 9 hours. So I put 3 in there and I click Add. So now I've got this factor here, hours of sleep with 3 levels, and I click Define. So now you can see that we have 3 separate spaces for these 3 levels, and I can put my 3 variables in there. And 9 hours, there we are. So there are a number of different options, but when you're completing the one-way ANOVA, the only one you really need to worry about is the Options tab. And this is so I can specify any follow-up tests that I want SPSS to do. So it's going to look across all the 3 levels and give me an omnibus kind of significance. Overall, is there a difference in hours of sleep? But I want to know if there are differences between 3 and 6 hours, 3 and 9 hours, and also 6 and 9 hours. So I need those 3 pairwise comparisons to be completed. So I take hours of sleep here and I put it over into this box display means, and then I'll ask it to compare main effects. So this is just going to compare each level of hours of sleep. If I've made specific predictions about differences between 3 hours, 6 hours and 9 hours, then I can click this None here. However, if I've not made any specific predictions, it's good practice to select Bonferroni. And this just means that those pairwise comparisons will be made more conservatively because I haven't made any specific predictions about them. When you come down to display, you can have descriptive statistics as well. It's always good practice to see those. And if you're interested in effect size, you could also click that. And you could also have a look at the observed power of your experiment as well. Significance level is at 0.05 and the confidence interval is at 95%, so we'll leave those as they are. So click Continue. And that's it, and then we'll click OK. So here's the output, so I'll just give it a sensible name. One-way repeated measures ANOVA for hours of sleep. And then you can see the output here, so the overall omnibus significance, the test of sphericity, which is gone through in detail in your worksheet, and then when you come down you have the pairwise comparisons as well for each level of hours of sleep. So we'll just give that a name there, and then we'll just save this. So this is 1 IV, more than 2 conditions. So we'll just save that. So to go back to our data sheet, now if I'd looked at my tests of normality, or looked at the data and I'd found that it wasn't normally distributed, then I would have to use a non-parametric test, and that is the Friedman ANOVA. So to use that, we'll go Analyze, Non-parametric Statistics, Related Samples, because each of the samples has come from the same group of people, and then Customize Analysis, because we're going to tell SPSS exactly what to do. Fields, we'll put 3, 6 and 9 hours, just highlight them all, into test fields. Go to Settings, Customize Tests, and then we'll have Friedman's. And again, multiple comparisons, it says all pairwise, so we'll leave that as it is. And then we click Run. There we go, and there is the output for the Friedman's ANOVA. And again, details of how to look at that more closely and interpret that is on your worksheet. So I'll just finish by giving that a sensible name so I know what it is, and click Save, and that's it.